to level 1, problem number 3. So it says consider a nested sequence of squares which are constructed in the following way. So here's the first square. It says find the midpoints, which they did here in purple, and then step 2 is connect the midpoints to form the second square. Then we find the midpoints of the third square, connect those, you have the next square, and so on and so on. We continue doing this repeatedly. Now, the question they're asking us, if the original square has perimeter of 32 units, so P1 equals 32 units, find P2, P3, P4. Find P1, P2, P3, P4. Well, let's start off by just drawing the first big square. So we start here, and if this has a perimeter of 32, each side must be 8 units. Of course, because the perimeter, remember, you just add up all the sides. Now they're asking us, okay, find the perimeter of square 2. So remember, square 2 is made by go to midpoint, go to midpoint, go to midpoint, go to midpoint, go to midpoint. So something leaps out here, first of all, and it'll be a little bit easier to see if we remember that a square has all right angles. So this square, if you notice, what we really want to know is how big is this orange side. If we could find one orange side, then we know the perimeter of the entire square. So we notice, of course, that there's a triangle that is forming. Perhaps I should go over a different color. Here's a clear triangle, and in fact, I could be a little bit more specific. This that I've shaded here in the dark green, that is a right triangle. And because this is a right triangle, I can use Pythagorean theorem. And now I can be a little bit more specific here about this. This is a right triangle, meaning this part right here must be 4 units long, and this part must be 4 units long. And of course, the reason is because these are the midpoints of these sides. If the side, of course, is length 8, the midpoint cuts it in half. Therefore, these are both 4 units. What I really want to find is this right here. How do I get that? I use Pythagorean theorem. To refresh your memory, Pythagorean theorem says that a squared plus b squared equals c squared. Well, one side is 4, the other side is 4, so we have 4 squared plus 4 squared equals c squared. 16 plus 16 equals c squared. 32 equals c squared. So square root of 32 equals c. It is often helpful to actually simplify this a little bit. And remember, 32 can be divided into 2 times 16. Square root of 16 is, of course, 4. So we have 4 root 2 equals c. Which means every side of this new smaller square, which remember, that's the square we want the perimeter of. If you add all this up, 4 plus 4 is 8, 12, 16. This is saying this perimeter is 16 root 2. Brianna. You can definitely keep it like this. Just on a multiple choice, like they might simplify for one of the answers. But it's for your response, doesn't matter. Okay, now we need to find P3, and we're going to use the exact same system we used here. Except instead, when finding P3, we want to start with square number 2 and then find the midpoints of that, because that's how they say they construct it. So I'm going to draw this, the smaller square, and each of these sides were 4 root 2. And now, of course, same process, just like it says, you find the midpoints of each side, so midpoint, 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 connect them in a square. Remember, these are right angles, because this is a triangle. And look again what emerges, this right triangle. Okay, we've got a right triangle here. So we're going to go through the exact same process to get this side here. So let's write down our formula. A squared plus b squared equals c squared. So what is a squared and what is b squared? Well, the question is what is a and what is b? So the question is, how much is this side right here? How much is this side right here? Well, if this whole thing is 4 root 2, this smaller piece, half of it, must be 2 root 2. Because remember, this is just half of the whole side. So let's plug that in, of course. 2 root 2 squared plus 2 root 2 squared equals c squared. Remember, when you're squaring, the squared goes on the coefficient and on the square root. 2 squared is 4, root 2 squared is 2. 2 squared is 4, root 2 squared is 2. 4 times 2 is 8, plus 8 is c squared. 16 is c squared. 4 is c. Which means all of these green sides are 4. So the perimeter of the square must be 16. 4 plus 4 plus 4 plus 4. Questions on this? And now we'll do the exact same process to get P4. I'll do that on the next page. Some of you may be ready to do that on your own. If so, go for it. But let me stop and see if there are any questions before I do the next part. Okay. Let me go ahead and find P4. So to get P4, I'm going to start by drawing triangle 3. So P4. And again, I'll move this up in 1 sec. I'm going to, sorry, not triangle. I'm going to start by drawing square 3. And this is now the green one that was here. Each side was 4. And what we need to do is find the midpoints of these. By now this is going to sound very repetitive, but again, a right triangle emerges. Right triangle emerges. Of course, each side of the right triangle is half of 4. Another way of saying that is 2. A squared plus b squared equals c squared. 2 squared plus 2 squared equals c squared. And now we've got c. Another way of writing this, of course, so each side of this blue square is 2 root 2. So the perimeter of the blue square is 2 root 2 times 4, also known as 8 root 2. Let me take questions on this. Drew, go ahead, please. Yep. That is not right for this reason. This is root 32. This is this. All right. Any other questions on part A? All right. Let's go to part B. So part B is asking us to determine if this is arithmetic, geometric, or neither. So again, these were the terms of the sequence right here. And we need to know, is this arithmetic, is it geometric, or is it neither? Well, let's find out. From here to here, what is happening? Well, R, which is the common ratio, if this were geometric, would be what? How do I go from here to here? Well, I divide by 2. 32 divided by 2 gives me 16. And then I multiply the top by root 2. This times this will give me this. 32 divided by 2 is 16. 16 times root 2 is 16 root 2. Same thing from here to here. R equals divide by 2. 16 divided by 2 is 8. Times root 2. So if only the R here was the same thing, then we know it's geometric. So we need to check. When I looked at this the first time, I was like, I don't think it's going to work. I didn't think that this times this would give me this. It doesn't look like it's going to work. So let's take a look. 16 root 2 times R. See what we get. On the bottom, 2 times 1 is 2. On the top, we have 16 times root 2 times root 2. Root 2 times root 2 is just 2. So we have 16 times 2 divided by 2, 32 divided by 2, which is 16. It does work. So this is our R, meaning we have a geometric with R equal to root 2 over 2. Questions on part B? Okay, let's go to C. C is purely, do you know the formula or not? That's all it is. C says, what is the nth term of this sequence? So for geometric, nth term is an equals a1 times r to the n minus 1. So an equals a1 times r to the n minus 1. Questions? Okay, so there's A through C. Let's now attack D and E. Before I do that, are there any questions on A through C? Alright, so D and E. Alright, so part D says find